All right, we're going to move along pretty quickly. Our focus in this session is to talk to you about the Istio service mesh technology, talk to you how it impacts your microservices architecture, how it impacts your Kubernetes and OpenShift architecture, and how you kind of build next-generation cloud-native applications. And we can move along really fast. How many people were here for Ray's presentation in this room just 2 sessions ago? Oh, only 2 of you, only 3 of you? Okay, not too many people here for Ray. So my version of this is slightly different than what Ray showed you, and if Ray comes back, he can sit here and heckle me if he shows up here. Is Sebastian here? Oh, he's missing 2 right now. So there's 2 other presenters at Oracle Code One who also do the same talk. So this is going to be the 3rd version of this. Hopefully you guys will like it. Mine's the Bruce Lee version. It's easy to remember. And actually, there's a reason why it's Bruce Lee version. And I told this story when I was at All Things Open. And it has to do with the fact that I actually was born in Hawaii, but I grew up in Alabama. So I have a birth certificate from Hawaii, and that's where my mom is from. She was a Kona coffee farmer. So literally, she picked coffee as a young child growing up in the Kona coffee district of the Big Island. And I was born there in the case of Honolulu. But my father was from Georgia, so he brought us back to Alabama. And so I grew up in Alabama, and I was like this young, half-Asian kid growing up in Alabama, and you guys really can't appreciate what that means, okay? Especially in 1970 in Alabama. He actually would take me to Bruce Lee movies, which you probably shouldn't take like a 4-year-old to a Bruce Lee movie, but that's okay. Back then we were a little bit more freewheeling. So I fell in love with Bruce Lee. He was kind of my superhero as a child. I did go back to Hawaii for high school and then back to Alabama for college, so I just went back and forth. But Bruce Lee is certainly one of my childhood heroes. So my father would actually take me to a movie like this one, Enter the Dragon, and literally that phrase has always stuck with me. And when we came up with the service mesh idea, I was like, okay, enter the service mesh. That's where I got the phrase from. So I always love putting this slide into my presentation. It's about your journey to awesomeness, how you basically craft all the skills that you need and how the skills build on each other to be that next generation application developer, that next generation of cloud native architect, if you will. And so like in Kung Fu or in the case of martial arts, skills build on each other. And one skill that you have to have in IT is DevOps at this point. And I could spend an hour talking to you about DevOps, how Dev and Ops have to work together to build software better together and deliver that software in a production ever faster, because as a software developer, your code has no value until it lands in production. I make that really outrageous statement to software developers all around the globe, and it does upset some people. So some people are like, what? I wrote really cool code, and I checked it into the source repo. Who cares if it compiles and builds? Right, it has to compile and build. And more importantly, it has to pass all its tests. And more importantly, until it lands in production and adds value to someone's life, and you can prove that by actually monitoring it in production, you've actually not added any real value. You just typed a bunch of stuff on a keyboard, okay? So think about that and think about what it means to be part of DevOps. Also think about what it means to be part of a self-service on-demand elastic infrastructure. In the days where software developers used to wait 3 weeks for a virtual machine, like when someone came to you and said, hey, I have a new idea for a new API or a new app, and you said, great, I think I can solve it with this technology, this framework, and this other technology. Let me assemble those things. And you went to operations and said, hey, I need a virtual machine with this version of WebLogic, this version of Java, this framework, that framework, whatever it might have been, this app server, this container, et cetera. And they're like, okay, give us a few weeks after you file your ticket. Well, that's a problem. We shouldn't be waiting weeks or days or even hours to get access to a virtual machine. And in the case of a Kubernetes-based architecture, you can spin up resources instantaneously based on an API, based on a quota-driven based system so that you don't go beyond your quota. But as a developer, that means you can instantly experiment with new technologies across the board, okay? So making it easy is important. Automation, we don't feed CDs into CD trays anymore. Anybody else remember the days when MSDN used to ship to your office? And it was a book of CDs like this. It was like a stack. And in the case of the data center that I had at the time, it wasn't really that official or formal. So we literally would sit back there and have a CD feeding party into our servers to upgrade the SQL servers or upgrade the Windows or upgrade the .NET, so whatever it was back then. So that concept of feeding CDs is no longer. Nor should you SSH in and yum install this and yum install that, systemd this, systemd that, initd this, apt-get install this. You don't do that anymore. You use something like Puppet, Chef, or Ansible, like the Ansible playbook, and you are able to burn that server to the ground and rebuild it from scratch with just simply running a script. And you should be able to do that en masse, right? I want to start up 500 new servers right now. So automation is super critical. You got to think in terms of your CI/CD deployment pipeline. What does that mean? Is it written on the back of a napkin? Is it on a whiteboard? Is it a PowerPoint slide? Or is it actually automated in some form or fashion, like with a Jenkins file in the case of Jenkins 2, so that it literally is an automated pipeline that moves that container image through your system, right, from dev to stage to production? Then we're going to show you advanced deployment techniques. So this is actually where we're going to focus on this presentation because service mesh really helps us here. All right, this is where Istio really comes into play. We're going to show you things like blue-green deployments, canary deployments, really smart canary deployments. Right, we have the ability to actually show you how to do a dark launch as an example. Of course, you get all the observability aspects and security aspects that come with Istio. So a lot of really cool things there. And your goal is to be like Bruce. Is that cool? I want to be like Bruce. That's kind of the ultimate thing here. So, great quote from Bruce Lee. Knowing is not enough, we must apply. Willing is not enough, we must do. Okay, so even though I showed you all those things in the first chart there, a lot of people will, think, oh, we kind of sort of do all that. Well, not really. We don't do that all that well. And as a matter of fact, we have a DevOps team. It's that team over there. They have no developers on the DevOps team. Well, you see, you already have a problem when you say you're doing DevOps if there's no developers on the DevOps team. Now, think about your application. And this is actually why this is so crazy for us as Java developers. I assume a lot of people here are Java people, but you might be a Ruby on Rails person, you might be a LAMP stack person, mean, Mongo, Enterprise, Express, Angular, Node. It doesn't really matter what stack you come from, what world you come from. We knew what our application was. We knew how to pack it all together. We knew exactly what we had to have. In the case of Java EE, we had to put our jars and our wars in our ears. You guys remember all that? We had our 10 gigabyte ear file at the end of the day, because people had to throw in all the PDFs for the schematics, and they had to throw in all the video clips that we might serve our users to for some odd reason. So we had these massive ear files, but at least we could get our arms around it. We knew what that was. And the reason things got a little bit strange is we started thinking about our application in terms of modules, or maybe independent subsystems, or maybe actual services. And those modules and those components started having a kind of a life of their own. This is where we're transforming in the way we think of software development, and we think about those components, and our application starts to fade into the background, and we start thinking about these things called microservices, okay? The weird part about microservices is that those things actually get scattered around a network, and we put a network amongst them. And this is where it gets really hard. So instead of having one big old ear file that we knew how to deploy, and our operations team knew exactly what version of WebSphere, WebLogic, or JBoss to drop it into, what version of the JVM they had to have, running on Solaris AIX or HPUX, and we knew exactly how to operationalize that, it was just one thing. Now we have 15 things, 20 things, 200 things to manage at scale. So this is really where something like a Kubernetes and a service mesh technology really start to help you a lot, because you now have to manage these things at scale. And as a matter of fact, the network is a problem. You also have to have all your own databases to properly do microservices, right? You got to have a database per microservice. That's what they say in the literature. And no one really wants to do that in most average enterprise that I've gone to. They still have one monolithic database. There's a whole book, by the way, we have for that to help you address that too. But you might have at least multiple API endpoints, meaning I might have to have some API governance, API gateways, some other entry points to that application. And this is net new, because we used to just have our SOAP WSDL, XML payload going out the front door, or maybe we just had our JSF-based app talking to our user base in some form or fashion. Now we have all these REST endpoints that kind of poke into our infrastructure as well. How do we manage that, and how do we deal with all that? So microservices is fundamentally about distributed computing. And this is where it gets us into trouble. When we had one monolithic application that ran wholly in one JVM, life was relatively easy. The challenge was you had a lot of cooks in the kitchen. You had a lot of developers. You might have a team of 20 or 30 or 50 people all trying to put their ingredients into that cake. And that's why it took so long, and why you had to have all these checks and balances, and why you had so many vice presidents who had to sign off on a deployment of that big old ear file, and it took 3 months to deploy it. In this new world, you're trying to get to the point where you're deploying every week, or maybe deploying every day, or deploying every Tuesday at 10 a.m. during the workday. And what we'll see when I get to the demonstrations is you could deploy every day or every Tuesday at 10 a.m. with zero downtime. That's kind of part of this new way of thinking. How do I deploy all the time in the middle of the production day? Not on Friday night, waiting for people to come back to work Monday morning, but what if we want to deploy in the middle of Black Friday and we're a retail outlet, as an example? Now, the problem with distributed computing is you have to remember the fallacies of distributed computing. Hopefully these are known to you, or you've heard about these before, or there's a nice little Wikipedia link there. But the concept of the network is reliable is certainly untrue. The network at this conference center is not reliable. Latency is never zero. Bandwidth is never infinite. And these things will bite you. And as software developers, we tend to forget that. We just think, oh, I'm just making an HTTP call from here to there, here to there, here to there. Now those are dependencies that you have, which have a network invocation amongst them. And what happens if the network is down? You're like, well, if it's down, I get an exception. I catch the exception and figure out what to do. Fine. That's not too hard. What if the network is just slow? And that is the insidious aspect of distributed computing that will destroy your application. Not that the thing is down. Down is easy. Slow is hard. Because it's connected. We didn't get an exception back. It's just taking like 7 seconds for the database to respond. What do you do next? Because your SLA for your API is 2 seconds to your customer. And now you have a 7-second dependency. How do you deal with that? So that's where you see the service mesh technology also helping you think about those problems. Okay? So if we go back to our diagram of services here, what happens if we have a failure of a single service, either a slowdown or a dead service? Is it a cascading failure throughout my network, throughout my service mesh? We have to be thinking about that. Okay? So in the middle of chaos lies opportunity. Gotta have all good Bruce Lee quotes. I got a bunch of them in this presentation, by the way. So again, get the bit.ly link at the bottom there, bit.ly ATO 2018, and there's a bunch more at the bottom of the deck. Okay? A short history of microservices, and this is pretty important to understand. We've been thinking about what it means to break up applications and waterfall processes and big old teams into smaller units for quite some time. In other words, we don't want a 50-person development team. We want a 8-person development team. We don't want a 5-month waterfall process. We want a 15-day sprint, right? We've been thinking about how we basically break things up, make them smaller, more actionable, and have smaller units that can be churned and iterated on faster. And the same thing is true of microservices. So when we did continuous integration with XP in 1999, we were trying to make things more automated and have smaller batches. When we talked about the Agile Manifesto in 2001, right? Those also impacted the world we live in. What about the cloud being born in 2006? And I just put Java E6 on here to give you perspective. You can see Java E6 was born in 2009. DevOps was also born in 2009, but it got really interesting when Netflix decided to move to Amazon, all right, in 2010. They had to go cloud native. They left their data centers, start putting their applications up in this ephemeral cloud architecture where services might come and go as they please, where VMs may come and go as they please, and they had to think differently about how to build an application. Dropwizard was the first people to show us how to build a fat jar. And actually, on the new version of this slide, I also have Vertex on here. Vertex actually shipped a month later with also a version of the fat jar. So we actually learned how to do these self-built, right, where all the dependencies we need is in a single jar file, as opposed to deploying my ear file to an application server. I had everything in a single jar that was self-executable. Dropwizard and Vertex showed us that. I have Hystrix and Ribbon and Eureka here. So Netflix open sourced their distributed middleware that helped them build a microservices architecture. And that changed everything about how we thought about software architecture. It was really at that moment in time, back in 2012, we're like, holy crap, Hystrix is amazingly cool. We never thought about circuit breaking technology before, right? Eureka for service discovery across multiple VMs of the Amazon cloud, Ribbon in the case of client-side load balancing. Now I see how I can actually make a resilient, elastic, strong call across the network to that other thing and be okay. Okay? It's well beyond what we had in the base JVM libraries for making HTTP calls, as an example. Microservices, of course, showed up on the ThoughtWorks radar in 2012, and then the perfect storm was really here. When we saw Docker being born in 2013, and we saw Spring Boot, and we saw Kubernetes and microservices officially being defined. So back in 2014, the world lit on fire for microservices. Everybody had to have it. Everybody's doing it now, right? Yeah, we're all doing it now. We might be doing it at differing levels and different kinds of ways of going about it, but this is what happened to us from an industry standpoint, is when all these things came together is when it got really exciting. Okay? So we actually like to talk about the microserviceilities a lot, and we actually can do like a 3-hour deep dive presentation, and we won't have time for that, obviously, to go through all of these little aspects right here. So you're responsible for your API. You build an application, right? Whether it be in your Node.js application, your Go, your Wildfly swarms now called Thorntail, right? Use MicroProfile, use Java E. It doesn't matter what you use. You're responsible for building your API with your Python app, your Node app, your Vertex app, etc. But then you have to have these other elements filled in to make sure you have a robust application architecture. What is our discovery mechanism going to be? What is our invocation model going to be? Are we using gRPC? Are we using HTTP? Are we using SOAP over, HTTP? Are we going to have an elastic infrastructure, meaning does it scale out and scale back easily? And that sort of thing. Is it resilient to failure or slowdown in those invocations? Is there a pipeline that helps me govern the process of moving my code from dev to stage to production? Is there an authentication authorization mechanism so that A calls B and that's allowed? We need to know that even if it's a service-to-service call in my company, that should be allowed and authorized, because I've worked with many big companies where that's not allowed. Just because you stand up a service doesn't mean everyone else in the company can pound on it. You stood up that service for a specific set of internal customers, and more importantly, there's actually regulations and governance rules that require the invocations to come through you through a certain proxy. You can't just be open to the wild, even inside your own firewall and in your own data center. Logging is a critical aspect of it as well. How do we capture the logs from all these distributed components all running around a big mesh of services? And how do I monitor it, and how do I trace it? So these capabilities are super critical to think about how do we get holistically in a microservices architecture. And so Kubernetes and Red Hat has OpenShift, right? So you can actually see I'm wearing my Friends of the Pods t-shirt. This is actually the podcast called Pod CTL, Pod Cuddle, Pod Control. It's like Cube Cuddle, Cube Control. And so that's also sponsored by Red Hat. We have a Kubernetes distribution that we sponsor, right? So it's called OpenShift. And Kubernetes nicely addresses a lot of these areas, right? So discovery you get for free. You don't need a Eureka anymore. It's out of the box. You don't have to think about it anymore. You want an invocation model based on opening an appropriate port across a service boundary? Piece of cake. Just works automatically if you're in a Kubernetes world, right, as long as you declare the service correctly. You want scale-out elasticity? No problem. It does that for you for free. You have a declarative state of what you want your application to look like, and you know you need 2 replicas of this instance, or 4 versions of that instance, or 2 of these and 6 of those, and it scales it out across the cluster, and if any node should die, it just scales it someplace else, right? Moves your workload where it needs to be. So it takes care of those kinds of things, but it doesn't really have a great resilience model. It has some resiliency capability, like the liveness probe and readiness probe, which is very, very powerful, but it doesn't have like a Hystrix-like resiliency model, okay? The pipeline integration, the Jenkins integration, we did at OpenShift, with OpenShift in particular. It's really kind of cool. We also did out-of-the-box EFK, so that's your Elastic, FluentD, Kibana logging kind of thing, apparatus. We also had Prometheus-based monitoring built in on the OpenShift side, but you can at least assemble all these things pretty easily. So there was a lot of stuff you could do by just simply adding, Kubernetes to the mix. Now, here's a great quote, another great quote from Bruce Lee. Adapt what is useful, reject what is useless, and add what is specially and specifically your own. Okay? So, we like to talk about Istio, which is another Greek nautical term. So Kubernetes is a Greek nautical term. You guys familiar with that one, right? It's the helmsman, ship's pilot, and of course we're dealing with these things called pods. Does anyone know why we call them pods besides Ray? Yeah, so pod is a family of whales, all right? And you guys know where the whales come from? A pod is a family of whales. This is actually very important because what you'll see when we get to that pod is we can actually have more than one container in it. And we never knew we could put more than one container in it. We thought one pod, one container. That's the way it's always been. With Istio, we have 2. And actually, if I was doing my Knative presentation and demo, you'd see 3. What the hell, there's 3? And yeah, there's 3 right now, and then maybe they'll get down to 2. But you can actually pack a lot of different things in there, and people didn't really realize that. And so this is why we have all these kind of Greek nautical terms. Istio means sail, like the sailboat, okay? And you can kind of see now where, if you look at our chart, again, your code is responsible for your API. That's your business logic. But discovery is augmented with Istio, resiliency is augmented with Istio, authentication is augmented with Istio, monitoring out of the box with Istio, and then tracing with Istio. So if you think of the holistic application architecture now, we've kind of covered our bases with these different technologies. And then you can kind of do some really awesome stuff with it, okay? And we're going to show you that before we run out of time. So before Istio, it would look like this. Okay, you had to have your JVM running inside your container, would have your service application logic, whether it be your Spring Boot application with your Spring Cloud annotations, right? Or it could be your Vertex application, your Thorntail application, your microprofile kind of thing. It doesn't really matter, right? As long as it was Java, you're okay, because this only worked for Java. If you're a Node, you didn't get this good stuff. If you're a Python, you didn't get it, okay? Netflix only built for Java. And this is where it came from. So we have Eureka, we have our Ribbon, we have our Brave, which actually integrated Zipkin, right? We had our various tools and our different jar files we'd include in our POM XML, and that's how we got these capabilities, okay? So that's what it looked like before Istio. After Istio, we just have the sidecar. And the sidecar container is specifically how you integrate these capabilities without impacting the business logic or your application code at all. As a matter of fact, your application code is completely unaware that this is happening, because traffic that it thinks is sending out is actually getting intercepted by the sidecar. It's using the magic of IP tables, by the way, if you're familiar with that level of Linux kind of manipulation. It's just really like a man-in-the-middle attack on yourself is how I like to think of it. Okay, so it's manipulating IP tables, so everything that comes out of that JVM application, it's going through the sidecar. The sidecar is figuring out where to send those packets to, right, to another application, perhaps a different one than you thought you were calling, and then a response has to come back through the sidecar. So your ingress and egress in and out of that pod is actually through the sidecar now, okay? So just be aware of that one. All right, showing off is a fool's idea of glory. Isn't that a great quote? It's a great quote if you have to do a demo of crazy stuff, so let's do it. Let's show you some stuff here, all right? We've been talking long enough. And again, keep in mind, this is the Bitly ATO 2018 deck, the Bruce Lee version I just launched this past week, but the real deck is here at Bitly Istio intro, okay? You can actually see my unicorn version of that Kung Fu thing. And don't forget, we are going to do the Twitter raffle. If you follow me with a picture of the session, mention Burr Sutter, and this is assuming Edson's solution still works for us, pound code 1, we're going to give away the Chromebook. But let's actually go in here and dig in here, okay? Let's see what I have running still. Let me just pull my endpoint. What I have is 3 actual endpoints here. So 3 microservices, customer, preference, and recommendation. So customer calls preference, preference calls recommendation. You can build these in any language and tool you want. Right now it's Spring Boot, and Vertex, but it could be microprofile, Node.js, and Spring Boot in that order. It doesn't matter at all. That's kind of the cool thing about what we're showing you here. So if I show you this technology, okay, and let's actually go look at recommendation. But before I do that, let's open up this, it looks like I got logged out. Get logged back in here. So I'm actually running all of this on a local instance, a local VM, with these 3 microservices. It should be noted they're all running on 8080. So the nice thing about Kubernetes architecture is you can run everything on 8080. You can have 45 JVMs running on 8080, assuming you have enough memory, okay? So that's important to know, because I'm running all these on 8080, and that's nice by itself. But now what I can show you is that we have the additional sidecar in here. So if I look at, you can look at it from the UI standpoint. You can see there's the actual image associated with that code base, example/preference colon v1. But then there's this Istio proxy in here also. So there's that additional sidecar. And it's really obvious also when you use the standard command line tools. So if I come over here and say kubectl get pods, I'm in the wrong project. So let's get the right project. Yep. And there we go. You can see right there it says 2 by 2. Because there's 2 containers that have to be ready inside each of those pods. And if I come over here and actually do a kubectl describe, deployment, customer, let's see if we do that correctly, and we look around in here, you'll see that it has the identification of the Istio proxy, as well as the address and other things that it has to have to actually call. All right, and we'll talk about this architecture in a second, but you can see it's specifically the Envoy binary that is that sidecar proxy. Right, so that's part of the architecture already, and it got injected for you either automatically or manually, and we'll show you that in a second. All right, but by default, it's just there. Your code is completely unaware of it. But what that means is you can kind of see with my little polar right here, you get some things for free right away. For instance, you get the Prometheus-based monitoring. And I can kind of come over here and actually see, based on my polar, that we actually have traffic moving through these different endpoints, my customer, my preference, and my recommendation. Okay? So we're seeing traffic there. You get out-of-the-box tracing. So if I come over here now, you can kind of see the latency amongst the services. So you can kind of see customer calls preference, preference calls recommendation. You can see the latency for the input and output of those service calls there. And that's kind of, again, something else you kind of get for free by simply having this installed. And one other thing I'll show you is we have been working on a different service graph. It's called Kiale, another open source project that you can add. And it has some really clever things here, like you can kind of see, you know, it has a little animation showing you the traffic flow right there at the bottom of the screen. Can I get this up a little bit? It's at the bottom of this browser here, so make this a little bit smaller. There we go. Just kind of raise it up there a little bit. But you can kind of see that's Kiale doing its thing down there. And it also will tell you things like the health and well-being of these services. Like I want to come over here and look at the tutorial. Yeah, let's look at the tutorial. That's the namespace I'm in. I can look at customer. I can see it's healthy, right? There's a lot of cool data you can get right away just because you have the service mesh installed, okay? And this is if you have several of these microservices, this sort of thing starts to matter. But let's actually go in here and actually have a little fun with it. I'm going to come in here and make a change to the code base. Let's see, where am I at? Okay, let's see here. I'm going to make a change to this Vertex code. So this is actually an example of a Vertex-based application endpoint. It is actually a super lightweight reactive toolkit for the JVM. Let's just call this code 1. Okay, and this is October 24th, right? Let's put that in there. I'm just making a change to the output of the string that gets returned. Right now it's returning recommendation from host name. That is the unique computer name that application thinks it's running on. And that's important to realize that every little pod is its own computer, if you will, from the JVM standpoint. And then there's a little variable there so you can see the life cycle of the JVM. Okay, that JVM's been up and running and it's gotten over 327 hits right now. It's just a simple counter. So we're going to let that be. And I'm also going to change the logger down here too. So let's also change the logger to code 1, include that. I'm going to hit save there. And in true Java form, I'm going to do a Maven clean package because that's what you do, right? Or Gradle, if that's what you might have. But my Maven clean package, it basically builds a fat jar for me. And it basically has this little fat jar here called recommendation.jar. So my whole application is packed into a single jar. All its dependencies are right there. And so I can do java-jar, target, recommendation, and there it's up. You notice it deploys insanely fast because it's Vertex. It goes super fast. All right, so I can curl it, and you can kind of see there's my code 1, October 24th, and you can see the instance variable. And notice it says unknown right now because it doesn't know what computer it's on right now. That variable is not set, but it will be once we get it in. Next thing you have to do is you have to build your Docker image. Okay, so Docker images, maybe I just want to make sure I'm connected to the Docker daemon. I am. I'm connected actually to the local Kubernetes cluster I have here as the Docker daemon is exposed there. So I can now do a Docker build -t example recommendation v2, and there we go. All right, Docker image built. And you notice it was built really fast because I already have the layers all cached. If all you're doing is updating the topmost layer, in this case just the fat jar, it's really super fast, right? Depends on how big your fat jar is. But there's different strategies for building Docker images. And now this is actually where it gets hard. In Kubernetes land, you have two files, additional files you tend to deal with, a deployment YAML and a service YAML, okay? The service is already deployed. Okay, in this case, if I come over and say kubectl get services, I already have a recommendation service deployed. But what's cool about this is the service is the virtualized IP address, if you will, that everybody is talking to. It is what everyone else sees about your universe, but you can have as many pods behind that service with completely different implementations in all of them. That's always been one unique aspect of Kubernetes that really makes a lot of the magic of Kubernetes possible. Everybody who talks to the service calls it recommendation. That's its name. They don't think of it as anything with an IP address. They don't think of it as having any kind of unique weird properties about it, right? They just call recommendation, and recommendation gets routed to the correct pod based on a series of selector labels. And if that pod happens to be implemented in Python this time, great. It runs the actual API. If it happens to be implemented in Java this time, that's great too. So that little bit of magic has actually always made this incredibly flexible from an architecture standpoint. I would say that's probably the core of what we see in Kubernetes magic is the service separation from the pod. So the cool thing is the JVM is completely unaware that the service is out in front of it, essentially as a proxy, as a gateway to it. Okay, so what I need to do is add my deployment, and I'm just going to copy and paste this line out of our tutorial, because one thing I'm showing you right now, okay, I'm simply demonstrating to you what we have in our tutorial. We have it's probably 6 to 8 hours or more of your day if you sat down and you can do all of these things on your own laptop. All right, so we wanted to document everything we possibly could. It's also embodied in this book. I will warn you though, the book being made of paper is already outdated, and we keep this thing running on GitHub up to date. Okay, so we want to give you some of the books. The books will give you some nice context, but really at the end of the day, the tutorial at GitHub is going to be your source of truth because we are always updating it. So I'm going to grab this little kubectl apply. Notice the Istio control line here too. Let me actually just copy that line out. Because what we do, because normally you just do kubectl, kubecontrol, apply, -f, the deployment YAML. Boom, you're off and running. In this case, right, we're going to use this Istio control. And it adds a bunch of stuff in here. You see this netadmin privilege. It's got the Istio proxy in it. You can see the port numbers for the init controller or init container. We got to do the volume mounts. We got to have all this other stuff in here. So this gets injected to your application. Okay, in this case, we're doing it manually. All right, but it can also be done automatically. as well. But you don't know as a developer, you don't have to know, okay? So we just want to show it to you here just so you're aware of it. By default, if I look at that deployment YAML, let's see right here. I'm just going to grab this right here. Dun, 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 and dun, dun. Let's see if I can just open it up real quick. Right? Here's what the deployment YAML looks like. This is the standard deployment YAML you see in Kubernetes land. You kind of see it has labels, label selectors, right? Pretty standard stuff there. JVM settings. It's always important that you set your heap size if you know how to do that correctly within a JVM option. In my intro Kubernetes class, I show you how we blow up the JVM, because the JVM does blow up by default. In a Docker-based, Kubernetes-based, or cgroups-based, it's a Linux kernel thing, application. So by default, the JVM grabs too much memory, in which case it gets killed. So the good news is, if it gets killed, it gets restarted. So I've actually had a senior manager in one of my presentations say, after I can even show you if you want, we can show you how it just dies and it gets restarted automatically, because Kubernetes is always trying to make it back to the state that you want, which is a running pod, not a dead pod. And a senior manager said, this is wonderful. My programmers write such bad code. If you're telling me Kubernetes will restart those things, and my operations team doesn't have to restart it every day like they normally do? I'm like, yeah, Kubernetes will restart it automatically. He said, that's huge. That's a huge win for me. And I thought about it for a second. I'm like, wow, that's pretty powerful. But it's not just if it's dead. Another thing Kubernetes will do is if it's not responsive, it'll also restart it. And that's a massive win. How many times have you forgot to put a proper finally block on your try-catch when you pulled something out of the connection pool or thread pool, and your app won't respond anymore? It's still alive, the port's still open, you can still send requests in, it's just no response ever comes out because your thread pool is dead. And you can't even tell it's down because it's still up, right? Kubernetes will actually ping it and actually get a response. If it doesn't give a response back in an appropriate time, it shoots it in the head and restarts it. Again, good for bad programming. I think it's just kind of funny. All right, but there's your image right there. And you can also see here's the liveness probe, which is what I was just talking about, the liveness probe, and there's a readiness probe here too. That's what I was just talking about, where it'll ensure that the state of what you want is good, and you basically can poke around inside that JVM. You can even do things like look on the file system with your readiness probe. In other words, it might be you have an old C++ application that its job was file input and file output, and it didn't have an HTTP endpoint. You can do your liveness probe, readiness probe with that. You can just look to see if a file exists, and it's good. If the file doesn't exist, something's wrong. Alert somebody and kill that thing, right? So that's kind of nice. But you can kind of see what it used to like before, and now what it looks like after. So let's copy this whole line in now. Right? We're going to just grab the whole thing. And I'm showing you this because I want you guys to be able to do this on your own. So we're still polling away over here. And let's do this real quick. kubectl, get pods. Okay, I'm going to watch my pods. You see I have 3 of them running, customer preference recommendation, run this. And if we watch closely, the new deployment request is we have version 2 deployed. You can kind of see it's bringing that pod online right there. 1 of 2 is ready. Okay, so it's got to be 2 of 2 ready because it has to have both the sidecar ready and my business logic container ready. As soon as you see it go 2 of 2, you see it in the load balancer right away, because the default Kubernetes activity is for every pod that you have, we round robin load balance across it. Right? So if you have 2, you get 50-50. If you have 3, you get 33, about 34. If you have 4, you get 25, 25, right? It's just round robin, and that's out of the box Kubernetes. You don't do anything for that. That's kind of what you get for free. So there we go. It's just rocking and rolling there, back and forth, back and forth. And now this is where it gets fun. Okay? Again, we showed you the observability aspects of it, the tracing aspects. You kind of get that all out of the box. Now this is where it gets interesting. You can actually start tweaking how these things deploy. And Istio allows you to do a lot of different things. If I go back to my little tutorial over here, you can kind of see we talked about monitoring and tracing, routing, fault injection for chaos engineering, circuit breaking. You can also protect egress. By default, egress is locked down. You guys so in other words, if you're familiar with a lot of security kind of vectors, security attack vectors, what people are trying to do is they're trying to get a Trojan into your application, right? So they basically have a backdoor built into your app. This can be very problematic, by the way, if you're just grabbing Docker images from Docker Hub, right? You're getting those images from someone you don't even know, and they could put anything they wanted to in there. But let's say you have that in your production environment. What you don't want, even if it does have an attack in your application, you don't want it to call out, because that way it gets the data out of your data center, out of your firewall, back to their server. So egress is automatically locked down in this architecture, which is awesome. And that's what that's for. And then there's a lot of other stuff that's in here too. Okay, but what we're going to do is show you kind of basic stuff here. Let's do this real quick. And I'm going to come back. I'm going to just switch windows here because I have a bunch of scripts to make this a little bit easier. We have what, about 10 more minutes? Is that right? Okay, so let me do this real quick. I'm going to just basically change my replica count. So what I'm going to do is I'm using kubectl scale replicas 1, deployment recommendation v2. What that means is I want 2 v2s, okay? I want 2 v2s of that coming up. And if I did that correctly, where's my second v2 at? I don't have a second v2. Let's do this. Kubectl, edit, deployment, recommendation, v2. Did I get the right one? All right. I don't know if you guys knew this, but you can actually use Visual Studio Code, by the way, to make your edit environment for editing these different objects within Kubernetes. So that's actually a cool trick to know about. But let me see here. Where is my replicas? Replicas 1. I thought I changed it too. Let's try that real quick. All right, save it. All right, close it. There we go. So that's what I expected to happen. I must have did something wrong in my script. But now we have 2 versions of v2 running there. And what you'll see happen is the load balancing take effect, where it goes 1, 2, 2, 1, 2, 2, 1, 2, 2. Okay, once it comes up. And so that is, again, just another Kubernetes feature you kind of get for free. But it's important to understand that because some service mesh features don't kick in until you have more than one replica. For instance, you want to have outlier detection, which is like circuit breaking, and you want to fail over in the case of a bad actor, right, a bad pod. But if there's no one to fail over to, Istio basically says, if there's no one to fail over to, we're just going to keep you on the bad one because there's no good one to go to, right? So you just have to remember how to have multiple replicas there. You can kind of see it going 1, 2, 2 now. I can go back to one replica. Let's go replicas. All right, right here. Oh, where'd it go? There we go. Now 1. Okay, and this, by the way, I'm using Visual Studio Code, which is one of my favorite tools. Red Hat actually provides the Java implementation for that, so you can kind of see where it says by Red Hat here. So 8 million plus downloads. It's a great little tool, and you can kind of see how I'm using it. I love just popping it open and doing what I want to do there. And there we go. We're basically going from, from 2 version 2s down to 1, changing our load balancer there. Okay. But let's do this now. Let's actually come in here and let's actually make everybody go to version 1, okay? And I'll show you what that is. Tutorial. It's actually basically 2 files. So if I come over here to the Istio files, it's 2 files. One called a destination. Okay, so like we go here, destination rule. Basically, destination rules have these labels. You basically say, I'm going to label v1 versus v2 is kind of the idea. And I'm going to have a virtual service as well. And the virtual service, in this case, it's going to say put 100% of the weight to version 1. In other words, send all traffic to version 1. If I look back over here, now you can see everybody is talking to version 1. And this is kind of interesting, because version 2 is still in production. But users are only seeing version 1. Okay? So this is where you start thinking about really interesting canary deployments. Have you guys heard the term canary deployment before? Probably too many times. Here, I have this in the slide deck too, just kind of run you through it real quick. All right, so the blue-green is very straightforward. Most people know what blue-green is. You have 2 versions, blue and green. And we're not going to, that's easy, right? That's out of the box. Kubernetes does that kind of for free. Looks like my network is not working. That might be part of my problem here. Okay, but as the build moves through the pipeline, it goes to green in this case, and the router switches to green. And because the router is all virtualized, that's easy. You don't have to do anything. You can do blue-green deployments like in your sleep in Kubernetes by default in OpenShift. But what happens if green fails? You go back to blue. The canary is more sophisticated, and it comes from the concept of the canary in the coal mine. Coal miners used to take, and maybe still do, take a little bird, and a yellow bird in a cage, down to the bottom of the coal mine. And the bird had 2 properties that it was really valuable. One, it's a nice, cute animal, and it sings and maybe entertains the coal miners throughout their day. But at any point that canary fell off its perch dead, you need to get the hell out of the coal mine. Okay? That was kind of the idea. So the same thing applies here in an application deployment setting. I'm going to take a small change, float it out to production. If it goes well, I grow it. If it goes poorly, I shrink it. It's real simple. And you just decide what percentage of your users are going to get that canary until it's everything that you see. So right now, what we have is version 2 running in production, yet only v1 is seen. And then we can decide to incrementally roll it out, okay? Let's go here. All right. So I'm going to roll it out now for 25% of my user base is going to see the version 2, okay? So let's just go look at what this looks like here in the code. Where'd my let's go here. Okay, so basically you're just changing the weight of 75 to 25 there. I want 75% of the users to go to version 1, 25% to go to version 2. And you can kind of see there's 25%. And notice it's not round robin. It's actually random. And that's actually kind of cool too. Random is actually more performant in the case of a highly scalable system. So you can see it's about 25% depending on the number of transactions coming through. And I can basically make a change, go back to V1 only, because my marketing team may say, you know what, we didn't want that change in production, please stop. Roll it back. And you can roll it right back. It's gone. And all of this is just a switching of those rules. And it's happening across your entire cluster, right? Entire service mesh cluster. It gets more interesting when we have something like this. I'm going to actually put the, let's do this. Yeah. I'm actually going to basically have version 2 still available. Let's see if this works for me. So this is version 1 on my Firefox. Let's go to Safari and version 2. So version 2 is seen only by Safari users. So what this means is you can use any HTTP header to make a decision as to which person gets to see the actual new version. So if I only want logged in users to see the new version. I only want employees to see the new version. I only want customers in New Zealand running Safari on an iPhone seeing the new version. You can get as specific as you want, all right, based on what you want. And the cool thing about that is that means you can have a very small set of users, like maybe only users who are logged in and check the beta box. They're beta customers, and that's how we do it. So that concept is having a very small set of users is a really smart canary, and that's something you couldn't do in regular Kubernetes, but you can do now. Okay? Let's see here. I'm going to just clean that out and show you one other thing. All right, I'm going to set up the dark launch here. Let's see how this goes for me. And so, there we go. So what I've done now is I basically said, okay, we still have version 2 in production, but I want no users to see it. Nope, not Safari users, not New Zealand users, not my iPhone users. No user sees it, but it's still being invoked. And what this allows you to do, if you're thinking about, I got to deploy every day at 10 a.m., or I got to deploy 5 times a day, I want to be like a Silicon Valley unicorn. We're going to deploy 4,000 times a day like Amazon does. You start thinking, well, I will just make code changes and literally deploy them to production, because there's no place like production. And the cool thing is, no user ever sees it. It's just running out there in the architecture. And you can then use this dark launch called mirroring concept that Istio also provides. And what it means is the code is still being exercised. It's just not responding to your user. And I've actually seen this used by a number of different organizations already for different types of rollouts that they do. They also want really high availability as an example. This gives you really high availability because worst case scenarios, you cut over to the other one if the other one fails, things like that. But what this means is you can now monitor it for CPU performance, for memory utilization. Is it throwing up a bunch of logs, errors in its logs? If it is, that's a bad canary. Let's find a new way to fix that code and roll it back out. So these kind of concepts, right, what you saw with the observability, what you saw with the tracing, what you see happening here are all very powerful aspects of how to deal with this architecture. Now, here's the thing that might be blowing your mind. This Istio stuff I'm showing you is actually kind of old now. We actually gave my first presentation on this a year ago at this conference. We worked on the GitHub repo with that big old tutorial you saw for the last year. We got the little book out and things like that. The next layer up is now Knative, which builds on top of these concepts, goes even further to give you serverless capabilities. All right, Justin was in the room talking about that earlier. But let's see here. I'm going to clean off the mirror, right? And then we'll go back to a normal round-robin load balancing. But we're basically out of time. There's other things I could show you in this, and actually there's the concept of circuit breaking, the pull ejector, retry. So literally if one of your pods is acting up and is throwing up 503s or errors or going too slow, you can basically reroute traffic around the bad actor until it eventually comes back and is happy. And that's another just set of Istio rules you can apply. So in our tutorial, we walk you through all these different types of Istio rules. Like here's the pull ejector one as an example. You can see it uses outlier detection. It's basically using as how many errors do we allow? How long is it kicked out before we go see if it should be brought back in, as an example. Different load balancing policies like random as an example there. You can kind of see we have there's a rate limiting as well. I might have an endpoint that can only accept so many users, so many transactions before it has to stop. And so therefore, I need to make sure we limit the rate to that. So you can see we have Firefox, mobile, different options here. And all of this is documented because what we knew is we can't teach you all this in 45 minutes. I run a 3-hour session of this with O'Reilly Safari Live. We still can't do it all in 3 hours. You guys need the opportunity to go try it on your own. Okay? So if you have access to the slide deck, There are 3-hour sessions that I do on this topic, but really the key thing here to understand is the bit.ly Istio tutorial. All right, now you guys got your tweets in. We need to do our Twitter raffle. You guys ready for that? Okay. Let's see here. Edson, this tool's going to work for me? Okay. And it's limit equal, right? All right, the first 10 we show here, you guys get one. You can run up and get one of these books. How about that? So let's do that. 10. All right, so we got this one from Agonor? Daniel. There we go. Daniel, you get one of the books. Are you still in the room? Come on. Now, the weird part is people might not be in the room. All right, Kevin Hulk here. You can have one too. All right, you got a nice Bruce Lee there. All right. Mr. Yanaga, we know who you are. No book for you. He wrote the application. There's Jonathan. Okay. Here's this one. All right, if you're here, you should be running up and coming and get one of these little books. Okay. Kenneth. And Goran Gecko, if you see your name, feel free to come on up. Okay, thank you. All right, we got Dior's. This one here, Fallacies of Distributed Computing, fantastic. Beto Salazar, all right, good stuff. Look at that, you guys actually took good pictures. I was at another conference and people were took pictures of the floor. They took pictures of the people with their head, behind someone's head. All right, so let's do this now. Let's do the Chromebook because we're out of time. And then we'll just give away the rest of the books individually. All right, let's see who gets the Chromebook winner. And that is KP Tranum. Woohoo! Fantastic.